So lesson 6 is something called the Atwood machine. I have a note here, video, a baffling balloon behavior. I'll show you that at the end of the class or another day, but I want to make sure I get through the lesson. What's an Atwood machine? An Atwood machine is a pulley system, as shown below. Or if you want to look up, here's an Atwood machine. An Atwood machine is where you have two masses hanging from a rope with a pulley where my top hand is. And so when one mass goes up, the other mass goes down. When the other mass goes down, the other mass goes. And here's the thing, are they connected by a rope? Then they must accelerate at the same rate. Now we're going to get a little magical, Courtney. To keep the math nice, we're going to assume our pulley has no friction. We're going to assume our ropes have no mass, because otherwise that would make for yucky math. But it's a thought construct. You know what a good example of an Atwood machine is? An elevator. Every elevator is actually an Atwood machine. Hang on here.
If there are any grade 9 students that have not had...
So here's a picture, a sketch, okay? We have mass 1, we have mass 2. Mass 2 is called a counterweight. A good example of this, Alex, are elevators. Any elevator that you go into, believe it or not, somewhere in that same elevator shaft, there's another mass that's actually the same mass as the elevator. So that all the motor has to lift is the people in the car. The counterweight cancels out the mass of the elevator, and we'll show you how that works in just a second. But for now, here's our thought question. Suppose we have an Atwood machine, a massless, frictionless pulley, massless ropes, and equal masses are put on either side of the machine, either side of the pulley, and one mass is lifted higher. When I let this mass go, what's going to happen? A, nothing, the system remains at rest. B, the higher mass is going to fall. Or C, the higher mass is going to go higher. Once again, this gives us a chance to vote. Once again, how high you hold your hand up is how sure you are of the answer. So in this situation here, there is lots of friction. I can feel it. But we're going to say, suppose I raise, which mass? This one. This mass higher. If there was no friction here and I let this mass go, will nothing happen? Will it fall down, or will it go higher? Okay? That's the question. Who says, got to be A, Mr. Duick, system remains at rest? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then Cohen did the... So I can decide whether he raised his hand or just scratched his chin. That was very smooth. Are you voting A or no? Oh, no. Okay. So what did I say, 10? Who says, no, Mr. Duick, you lifted something up. Gravity's going to pull it down. The higher mass is going to fall down. No one. Who says, no, Mr. Duick, the higher mass is going to keep going up? Everyone else? You know what? I think we can prove this. And I think we can prove this by zooming in on the right-hand picture and doing a force-based or a free body diagram. You ready? This mass right here, Courtney, the left-hand mass, what are the forces acting on it? Get the obvious one. I totally agree. mg. What else? Is it touching the floor? Say no. So is it sitting on a surface? So is there a normal force? No. Is there a rope? Oh, what have we called that one? Like you're feeling right now? Yes. Tension. Matt, what about the right-hand mass? What are the forces acting on it? Get the obvious one. Now, normally, because these are two different masses, I would call one M1 and one M2. But did the question say both masses are identical? Oh, then why don't I just use M and M for both of them? What else? Yep. And that's it. That's it. Who's winning? Well, the fact that most of you picked C meant that you think this is moving up, accelerating up. Follow it, follow it, follow it, follow it, follow it. So it seems that you're saying that this is winning. Is that okay? Let's see if that's right. Winner. This tension here, winner or loser? If we define down on the right as winner, what's this tension here, winner or loser? Loser, so minus. Now this tension here Also looks like a loser because it's pointing up. But if I follow it all the way around, which way will it end up pointing on this side? Down, winner? Right? And this mg here, Cohen, might look like a winner because it's pointing down like this mg, which I said was the winner on the right. But if I follow it, which way does it end up pointing when it gets to this side? I think up. Yeah? You got to use your imagination and imagine the arrow curving around the corner. But you can do that. Yeah. So loser. And that equals m1 plus m2 times a. Why is Mr. Duick so relaxed? And so that leaves me with mg minus... Wait a minute. Why is Mr. Duick a little nervous? In fact, what does the whole left side work out to? Because now I have mg minus mg. What's that? I get this. 0 equals... You guys learned this year when you're solving quadratic equations that if you have something times something equals 0, one of these somethings has to be 0. Are the masses 0? No. You know what must be 0? And so if your acceleration is 0, what answer must be correct? A, B, or C? Gotta be. And this is actually why then an elevator will have an identical counterweight, because what that means is if the elevator isn't moving, the motor can shut down and it's perfectly safe. Nothing's going to move around. Saves energy. If there was an imbalance, the motor would constantly have to be working against that force. Clever engineers. It says, using principles of physics, explain your answer. There. Drop the mic. Really, that's a proof. Shut up, there, walk off. So let's do one with numbers. In the diagram below, M1 is 6.2 kilograms. If you want to, you can fill it in, 6.2 kilograms. M2 is 2.8 kilograms. I don't know, that made it messier, whatever. It says, write force equations, find the acceleration, find the tension in the cord. Before I even do that, I think I'm going to label the forces. Okay. Okay, Ryan, what are the forces acting on the left hand on mass 2? Get the obvious one. I'll call that M2G since they conveniently labeled that as M2. What else, Ryan? I totally agree, like you're feeling right now. Yep. That's it, because it's not on the surface. What about on the right-hand mass, Ryan? Get the obvious one. M1G, I'll call that one, yes. What else? And I'm going to argue that the tensions are the same because they are the same rope. And I said last time, there's no way that you can tug on one side of a rope and not have exactly the same force on the other side of the rope. Is that okay? Who's winning? The bigger mass. And I think that's reasonable, yeah? The heavier mass. In other words, I think this system, if those masses are accurate, this is going to go plunging down, this is going to go plunging up. And eventually it'll hit the top, but we're going to pretend that's not going to happen. We're just looking at right now, this moment, this snapshot in time. Who's winning? Which force is that? That's not a force, that's a mass. What? Okay, you know what? Scene 1, Act 1, Take 2, and action. Ryan, which force is winning? I knew you'd get that first time. You were ever so clever. Thank you so much. So what that means, Ryan, is I've just decided that anything that ends up pointing down on the right will be a winner. Anything that ends up pointing down on the, up on the right will be a... Why'd you look on Prith when you said that? Did you see it? He went, loser, and he looked at you. Wow! Okay. Who's winning? Now let's walk along the rope. The first force I run into is this T right here, winner or loser. So that means minus. The next force, walk along the rope, walk along the rope, walk along the rope. The next force I run into is this T here, which you might be tempted to say was the loser, but when I follow it, what about this M2G? When I follow it, which way is it pointing on the left-hand side? What? So when it gets to this side, which way will it be pointing? Need an arrow, Mr. Dewick. Gosh. Pencil. Pointy part. Which way will it be pointing when it gets to the right-hand side? Up. So it's going to be up. Did it again. It's going to be a loser. A minus. Is that okay? Yeah, right? Is that okay? Okay. Sorry, I'm just giving Prith a complex because you know it's fun. Now, pause. What does winner minus loser always equal? Well, it equals MA, but did I have more than one mass on the left-hand side? Then I better have more than one mass on the right-hand side. And Jess and Ty and those of you that were away last class, this was the extra step we added if there's more than one mass. I love it when I lose tension. Okay. So here is the answer for part A. Part A said, write force equations. Done. Right, keep going. What does part B want me to find? Thank you for cluing in that was my abbreviation. Actually, I wanted to leave more room to work. Anyways, solve for the acceleration. How would I get the A by itself? Yeah. No. This is multiply. I'm going to divide the bracket. So the M1G drops down like a domino and the minus M2G drops down like a domino. I'm going to divide by that. You okay with that, Rye? And if you don't mind, I'm going to put the A equals on the left-hand side because that's kind of where I'm seeing stuff. Do I know mass 1? Yeah. Do I know G? Yep. Do I know mass 2? Yep. Do I know G? Oh, plug and chug. Is this a fraction? Is there more than one thing on the top? So what will I remember? And is there more than one thing on the bottom? So what will I remember? Brackets around the bottom. In other words, on my calculator, I'm going to put a bracket there and there and a bracket there and there. I don't think I need brackets anywhere else. It's going to be... Do this one in your head, Mr. Dewick. This is about my limit, unless the numbers are really nice. I don't think they are this time. It's going to be bracket 6.2 times 9.8 minus 2.8 times 9.8, close off the top, divided by bracket 6.2 plus 2.8. This is going to accelerate at almost exactly, but not quite. Is that right? 3.70? I'll go 3.70. 3.7. Meters per second squared because it's an acceleration. Well done, Ryan. What direction is this one going to accelerate? The right hand. What direction is mass 1 going to accelerate? Down. What direction is mass 2 going to accelerate? Up. This is actually why it's more convenient to let down be positive and up be negative, because I got, which one's positive, which one's negative? You know what? Do whichever one makes the math easier, because I got stuff accelerating in two different directions here. Is that okay, right? What's the third thing they wanted me to find? Part C. Well, I'm feeling the tension, Mr. Dewick. No, we can find the tension. We're going to find an individual force by looking at an individual mass. Okay? Look at both masses. Does any one of them have more forces and look yuckier than the other one? So they're about the same. Remember last day there was some that looked obviously really yucky, and Sheldon, when you're done blinking, we said, you with me? I thought I saw the... No? You're good? Okay. So these are about the same amount of work, but you know what? In which one is tension a winner? Mass 1 or mass 2? Which way is mass 1 accelerating? Which way is this mass accelerating? Down. Which way is tension pointing? Which way is this mass accelerating? Which way is tension pointing? Well, this is mass 1, this is mass 2. We can use numbers and names. Which way is mass 2 accelerating? Up. Which way is tension pointing? Which way is tension pointing? I don't care about, I'm talking this one here, right here. Which way is mass 2 accelerating? Okay, you're making this tougher for me, Matt. Which way is the smaller mass, the lighter mass, mass 2, the one on the left, accelerating? On the left, which way is tension pointing? That's the winning direction. I'm going to use that one. Because my equation here, looking at this, is going to be, who's winning, Matt? Because that's in the winning direction. Who's losing just over here? Who's losing just over here? And now I'm just looking at one mass, not both masses. Do you see why I did that one? Because it's easier to get the t by itself. How would I get the t by itself? Okay. Or I could have done this. Don't write this down, but just watch. I could have gone, who's winning? M1G minus tension equals M1A. I'll get the same answer no matter what. And here I would have done, Ryan, we've seen this dance before, that little thing, which we've done a bunch of times before. Yeah.
For part B, I think I'm using the same numbers that it comes at 57.
You've got a typo on your calculator. Did you clear your calculator? Have you cleared your calculator? Have you hit the clear button, or are the numbers still there? Okay, then I guarantee you made a typo, and show me later, and I'll walk through how you're typing it, but we'll carry on, okay? So, Matt, how would I get the t by itself? So it's going to be M2A plus M2G. How big is mass 2? Make sure you get the right mass. Good. How big is A? I just found it. 3.7 plus. How big is M2? 2.8. How big is G? 9.8. I'm going to use my answer button. So I'm going to go 2.8 times answer button plus 2.8 times 9.8. Tension is 37.8 newtons. You'd get the same answer with the other mass. That's the Atwood machine. We're just going to do a couple more. I'm even going to go chunk. Let's go straight to example 4. Let's find the acceleration and the chord tension if mass 1 equals 12.5 kilograms and mass 2 equals 24.6 kilograms. Okay. Which is the heavier mass? The one on the left or the one on the right? Which mass is going to accelerate down? The one on the left or the one on the right? Which mass is going to accelerate up? The one on the left or the one on the right? Okay? And this may seem obvious, but I'm not joking. I need to make sure I can figure this out. All right. What do they want me to find here? Looks like they want me to find the acceleration. I'll call that part A, and the tension, I'll call that part B. This is a job for a free body diagram. Lydia, my angel, looking at the left-hand mass, what are the forces acting on it? Get the obvious one, which is going to be M1G. What else? Yep. What about on the right-hand side? M2G. Tension. Which mass is bigger? So which mass is winning? Sorry, I got to be careful. Which force is winning? M2G. So anything that ends up pointing that way when it gets to that side. You okay with what I meant, Ryan, with the arrow changing and pointing? Yeah, okay. You got to use your imagination a little bit, but you can kind of follow it around. Is going to be a winner plus. So you ready? Who's winning, Lydia? Which one? There's two of them. M2G? Yes. I'll call this part A. M2G. And now, Lydia, we walk along the rope. This tension here, winner or loser? She did it too! Wow! Prith? You could do better. Just saying. So I did this same stupid joke yesterday with my other class, and then I had a kid blurt out, embarrassed, "No, Mr. Dewick, I didn't look at him. I looked at you." Oh! And then he just realized that he'd walked into my trap. It was great. Lydia, let's keep going. What about this tension here? When I follow it, what does it become? A winner or a loser? I think you're right. I just couldn't hear you. Can you say it with loud and proud authority and your confidence in your voice? Right? You guys see what I mean? When it gets to this, because I know it's pointing up on the left, but if you follow that arrow, right? Follow that arrow, it does end up pointing in the winning direction when it gets to the right-hand side. And this is what an Atwood machine can do. It lets you flip forces around. What about M1G? See what I've done? Did I mention something at the beginning of the year about self-esteem and damage? I hope I did. And it's more than one mass, so it's going to be M1 plus M2 times A. Spring break coming up. You guys going to relax? It starts now. Gotta love it when I can lose tension. Lydia, how would I get the A by itself? So it's going to be M1 plus M2 on the bottom. Really, this is a continuation, Sarah, of the lesson from yesterday with more than one mass. I just stuck a pulley in there to give us a full 180-degree turn. I think now it's plug and chug. M2, 24.6. You know what? I need more room, Mr. Duke. 24.6 times 9.8 minus 12.5 times 9.8 all over both of them. 12.5 plus, and Trevor, try typing this one in. I'm going to guess it was a bracket glitch. No. This is, look, I know I handwrite that, but the only brackets, so I'm going to put a times there. I'm going to put a times sign there, not a bracket. The only brackets I'm going to type on my calculator are those two in red and those two in red. Everything else is going to be a plus sign or a times sign or a minus sign. It's way easier to read. Hopefully I've gone on the occasional rant about good calculators. I'd like to think I have. So 24.6 times 9.8 minus 12.5 times 9.8. Close off the bracket. That's it. Divided by bracket 12.5 plus 24. By the way, this also emphasizes why, Sarah, it's so important. Bring your own calculator that you're familiar with, that you know how to make work. It always seems like every year I got a couple of kids that struggle in physics, are getting bad grades, and conveniently or coincidentally keep borrowing other people's calculators. I think it's because they don't know how to make them work, and so they're getting stuff wrong, and they don't realize it. You get 3.19622, 3.2? Because the 9 will become a 0 and the 1 will become... Is that right? Oh, and if I haven't said so already, I like this question. You're going to have an Atwood machine question exactly like example 4, but with different numbers. You'll have to figure out which way which one's going up, which one's going down. Whichever one is heaviest is really what you're looking for. And then I'll say, find the acceleration. John, find the tension. Sorry, what was it? 3.2? Lydia, 3.2 what units? Okay. What does part B want me to find, Lydia? Core tension, like you were feeling right then. Yeah. You can find it with either equation, but since each mass has two forces on it, I'll pick the mass where tension is a winner. In which mass is tension in the winning direction, mass 1 or mass 2? And really, let's generalize this. Aren't both tensions pointing up? So really what I'm saying is, hey, which mass is accelerating up? I'll use... I think mass 2 is the heavier mass, is it not?
Oh, sorry, mass 1.
I think mass 1 is accelerating up. Yeah? So I'm going to go like this. I'm going to go tension minus M1G equals M1A. You okay with that, Court? How would I get the T by itself, Courtney? Oh, okay. Yeah. Remember how weird that formula manipulation thingy seemed like 3 months ago? Hopefully you guys are cluing in. Again, this is why for this unit I told you I can't give you an equation. Well, winner minus loser equals MA, I guess. But we're adjusting and adapting it to our free body diagram, Hedrick, and our method. So you plussed it over, yeah? And I still have A stored on my calculator, so I'm going to go, what was M1? M1 was 12.5. I'm going to write 3.2, but I'm going to use my answer button. You get 162.4, 162 newtons? Bigger masses. You could have used this one, just to show you for what it's worth. It would be M2G minus tension equals M2A. You'd get M2G minus M2A equals tension. Just to show you that that it works, you would then get 24.6 times 9.8 minus 24.6 times 3.196, because that's what the acceleration was. And sure enough, I also get 162.45 newtons. Doesn't matter which one you pick. It's just one will be easier. Of course, I forgot to write down the answer. 162 newtons. Holy smokes, Mr. Dewick, a short lesson. We're done. I would love to find the missing mass. I'm going to nuke that. It's cool. It's cool. I think you can try in your homework number 1. You might be able to do these right on the paper. Number 2. Yeah, skip the finding the mass questions. I'm going to gamble and say just with 2 of them that you can figure this out. Okay? I was going to teach you how to find a missing mass given the acceleration, but I want to give you time to practice this. And I got a couple of cool videos to show you.